90% of victims in Africa hemorrhage to death. The cult were apparently investigating using the virus to create a biological weapon. Here, for the first time, was evidence that a terrorist group with serious intentions to kill on a mass scale had set out to make such a weapon.
It's absolutely clear that the latent capacity to produce and use biological weapons is increasing. It's also evident that terrorist groups are becoming more inclined to commit indiscriminate acts of mass violence than they have in the past. And one of the things that I worry about personally is the convergence of those two trends.
In the last 12 months, it's emerged that almost anyone can get their hands on the necessary bugs.
Yes, I'd like to place an order here to 0068-562. That'll be Yersinia pestis, Bombay strain.
A former member of a white racist group, Larry Harris, demonstrated how easily an extremist could obtain deadly germs. Posing as a medical researcher, he contacted a lab.
I ordered 3 vials of bubonic plague. And basically, get a catalog off the shelf, reach through, call them up, give them a charge card number, and they send it to me. Plain and simple. Yes, that is Yersinia pestis. That is correct. As far as a person getting into the biological business, you need nothing more than a very small laboratory. If you look at the size of this room, it's probably 10 by 12. And I have everything here necessary. I could easily work with plague, anthrax, cholera, typhoid, brucellosis, tularemia. It's very easy to obtain.
Harris's only mistake was to chase up one of his orders too eagerly. The police were called in by the supplier of microorganisms, the American Type and Culture Collection. At his trial, Harris claimed he was making vaccines for his family and their own protection. He isn't shy of enthusing about germ weapons.
Biologicals level the playing field. Before, you had governments with massive stockpiles of nuclear weapons, with aircraft carriers, with all types of machine guns and stuff of this nature. The private populace did not have these. But now when they become so oppressed, the private populace is going to go with a weapon that will give them the level of the playing field. And understand, trying to use a tank, again, a bottle of germs, is stupid. Aircraft carriers become obsolete. Submarines become obsolete. You are dealing purely with a weapon of extreme power.
Making a biological weapon is, however, not quite as easy as Harris makes out. Compared to making plutonium, growing bacteria is cheap and easy. But that's a long way from having a usable weapon.
The first stage is relatively straightforward. Any microbiologist with a little bit of access to non-specialized equipment can manufacture biological warfare agents at home or in a very rudimentary laboratory. But that's not the end of the story. Just having the stuff in a liquid form is not the end of the story. You need to get it into a form whereby it can get inside the lungs, it can be inhaled, and it can then cause the damage, and that's the tricky part.
The first problem is that the bugs are living organisms which can die in strong sunlight or cold temperatures. They must be kept alive until they are needed. Secondly, the bacteria have to be an exact particle size to stay airborne and pass through the mucous membranes in human lungs. But the biggest problem facing a terrorist is the risk of infecting themselves.
Let me set this aside.
Extremist groups suggest that simple face masks can protect you from contamination.
Now, you really have some lethal stuff here.
In biological research institutes, people don't leave their chances to such basic equipment.
It's clear any terrorist that considers producing or using a biological weapon is going to put themselves at some considerable personal risk. And we believe that weighs fairly heavily in their calculations. These are very dangerous organisms. Exposure and infection is often invisible. It's tasteless, odorless, you can't detect it, and you won't know for some time whether you've got it.
But it's not impossible that someone could succeed, despite the risks and technical difficulties. And if they did, the consequences could be devastating. The scenario the authorities fear most is a small group of terrorists who set out on the Hudson River with a plan to attack New York City. They have obtained a canister filled with enough bacteria to kill 500,000 people. They have waited for the right weather conditions, a gentle westerly breeze. They release the germs into the air using a converted paint sprayer, and the lethal cloud drifts towards the densely populated city. At first, it would seem like a sudden mass outbreak of flu. By the time the emergency services realized that it was a deadly epidemic, many victims would already be beyond treatment. Hospitals might not have enough antibiotics to deal with the numbers falling ill. There would be panic and chaos as the infection spread.
My personal opinion is that a major act of biological terrorism is far from inevitable. It's in fact quite unlikely. But given the severity of the consequences, I think it's likely enough to take it very seriously at the level of our governments, to be doing much to prepare. Second point is that I believe that likelihood, while low, is growing, and that should give us pause and reason for concern.
Go ahead, Bob. Well, we're saying that more and more people are going down. You received a report from the field, radio transmission.
Get that chair over there and let's get him out of here. Come on, Jack, let's go.
Following the Shinrikyo incident and the Larry Harris case, just over 2 years ago, the US set up a new program to prepare American cities for biological and chemical attacks.
We have a secondary device. We want to address Larry, Tommy, and Stevie, all right? Larry's going up on the primary device.
The Domestic Preparedness Program is a series of training exercises coordinated by the Army. Today they are showing Boston's emergency services how to reduce panic and how to protect themselves from contaminated casualties. The commanders who coordinate the program are keen to promote its value.
Being aware is a primary piece of being ready. And if we can make the cities aware and those critical first responders aware, we can make a bad situation not as bad.
But can they? As part of the training program, the US Army also demonstrate how they would set about defusing a potential biological bomb.
All right, no.
It all looks very high-tech, with a shrapnel-proof foam-filled tent to kill any bugs that have been let loose by the explosion. But the problem with a terrorist attack is that you wouldn't know it was coming, so there would be little chance of being able to defuse the weapon. Back in Boston, although the training looks impressive, it isn't solving how the city's hospitals would cope with a sudden epidemic of an exotic killer disease. In Britain, the approach seems to be to leave it all to the intelligence services.
The UK's response to terrorism as a whole is very much intelligence-led, and that means that the UK is looking at the people that might wish to do us harm, it's assessing their capabilities, and it's trying, wherever possible, to prevent them from enhancing those capabilities.
But should this approach fail to spot a terrorist attack, the health service here are poorly prepared to deal with the victims.
I certainly have no experience of a large-scale epidemic and have no experience in looking after large numbers of infectious patients. Conditions such as plague or anthrax, for most doctors working in Britain, would be encountered only in books, either textbooks or the Bible.
The only comfort is that making biological weapons is so risky and so difficult that it would be beyond the capability of many terrorists. But there is no such comfort on the battlefield, where there is now a real threat that biological weapons will be used. In warfare, the risks involved in making biological weapons, a risk which so far has contained the terrorist threat, can be largely overcome. And in the aftermath of the Gulf War, it has emerged that the potential impact of biological weapons could be greater than ever before. But the fear of germ warfare is not new.
There's a new poison. 1 ounce can kill all the people in the United States.
Germ warfare can wipe out an entire city.
Enemy agents could contaminate the city water supply. How can we protect ourselves from BW attacks?
As the Cold War intensified in the 1950s, fear grew in the United States that the Soviet Union might be developing bioweapons. The Pentagon ordered secret experiments to discover the consequences of an attack by Soviet undercover agents. In several major cities across the USA, FBI men dispersed clouds of bacteria to test how far they would travel. Concern about biological warfare was so great that Britain was also prepared to experiment on its own citizens.
There were many trials carried out in both the UK and the United States, and a certain amount of cooperation on seeing the effects of biological agents delivered by a number of different means, be it unorthodox means, sabotage type means, from unconventional, maybe an aerosol generator in the back of a truck or on a boat offshore. So a lot of trials were carried out, but these were for defensive purposes, because it was felt this was the most important way of trying to deal with this particular threat.
Meanwhile, the hunt was also on to develop their own reliable, effective weapons. One bacteria, anthrax, seemed to be promising for weaponization. Anthrax is a tough organism. It survives extreme climate conditions and can lie dormant for 40 years. It causes blood poisoning and septic swellings. By the time the symptoms appear, it's often too late to save the victim. The British used sheep to test anthrax on an island off the coast of Scotland. They invented bombs and spray delivery systems which could disperse it in the air. The experiments showed that just a few grams could cause many casualties. But anthrax and other germ weapons proved unreliable. One change in the wind direction meant your own troops were infected, or that the attack failed altogether. The inability to create reliable weapons led the West to give up their stockpiles and sign a treaty with the Soviet Union in 1972, banning further research.
Well, the key reason that the United States and Great Britain gave up their biological warfare capabilities is that they didn't think they were very useful. The military commanders didn't really see a contingency in which they'd ever want to use these things. They were hard to predict, hard to control. The adversary could retaliate with nuclear weapons.
The threat of biological warfare seemed to have gone away. But it was an illusion. During the 1980s, intelligence reports suggested that the Russians had not really given up their program. Then in the late 80s, Iraq was reported to be acquiring bugs and microbiologists. These reports were taken seriously enough that British and American soldiers had to struggle with bioprotection suits as they prepared to fight Iraq in 1991. Then the following year, Dr. Ken Alibek, a key microbiologist from Russia, defected. The fears of Western governments were confirmed. It turned out that during the Soviet era, Russia had secretly built up a vast arsenal of biological weapons.
According to the Soviet Union's philosophy, concept just to develop such weapons, any possible agent, biological agent, that could be valuable for testing and applying in future biological weapons would be tested, would be developed, and would be turned into weapons.
Alibek worked at the Stepnogorsk plant in the desolate region of Kazakhstan. At this and other sites, the Russians worked on all aspects of biological weapons. They tested new and more deadly disease agents and developed sophisticated ways of delivering the agents at long range.
So the Russians were working away on all this and had a range of agents that could be put in mainly missiles. They saw it as a strategic weapon. If you look at the time when they accelerated their development, they really pushed in, and I think that the scale of their program, I think they had 25,000 scientists working on it at some stage, and millions of dollars of worth of money being poured into it. And this was in the early 80s, at the time of the Star Wars. And it's clear from evidence that we now know that this was a technology where they thought, we have the edge, we must develop this, this will be a big surprise. Of course, they were absolutely right.
The Russian program created an army of scientists with knowledge of the very latest technology in germ weapons. With the collapse of the Soviet regime, most of the program has been dismantled, leaving them without jobs.
My colleagues, a lot of them now are unemployed, and they've got nothing in many cases just to feed their families, their children. Some of them sell flowers in streets, very good, perfect scientists. And many of them are very angry now because of situation in Russia. And now if, for example, they received a proposal to do something for Iraq, for Iran, I cannot exclude they would do this.
There are plenty of countries who might offer them work. The US Defense Department suspects 16 of having bio-warfare programs, including Syria, North Korea, Libya and China, along with Iran and Iraq.
There's been a proliferation of technology from countries that maybe formerly had offensive programs. And that concerns us the most, in that the knowledge about how to deliver the agents, which is the most critical part, may now be available to adversaries of the United States.
It was clear to the Allies that if the Iraqis possessed biological weapons, they might well be prepared to use them. After all, Saddam Hussein had not flinched from using chemical weapons to gas Kurdish villages.
Biological warfare agents kill anywhere from hundreds to thousands to tens of thousands, depending on their employment. You can't see them, you can't feel them, you can't touch them. There's terror associated also with just the threat of use of biological warfare agents. So from that perspective, they become a weapon that is very, very lucrative to those folks who may in fact be facing a force that is superior both in firepower and in capability.
At the end of the Gulf War, with revelations about Russia and continued suspicions about Iraq, it was essential for the Allies to find out whether the Iraqis did actually possess biological weapons. With the backing of the United Nations, inspections began.
You take your hand off my inspector now. I have instruction from my boss. Take your hand off. Not from you. You do not touch my inspector. I don't touch him. You're touching me. If you touch me once more, I just talked to Mr.
They wouldn't admit to a program, and they even showed a group of journalists around their main production plant in early 1995, where they were saying, here is a single-cell protein plant, that's something which produces an additive for animal foods to improve its qualities, and also this is a biopesticide plant. And a key person in the program was showing these journalists around, saying these are perfectly innocent places.
Just 4 months later, after a high-ranking defector spilled the beans, the Iraqis had to admit that these apparently harmless pesticide plants were actually producing anthrax and other agents. Some of the factories have now been destroyed, but we still don't know the full extent of the Iraqi program.
They attempted to produce biological warfare agents, and they succeeded. They'd also made the next step and put these into means of delivery and have begun to fill weapons and actually make them ready for use. So they were, and they still are, because we haven't got to the bottom of their program, a nation of very great concern.
The Iraqi anthrax missiles were designed to detonate on impact. This might have destroyed most of the organisms. It's not yet clear whether the Iraqis had managed to solve the technical challenges of delivery.
That's not a terribly sophisticated design, and it's certainly not something that the U.S. military would regard as an efficient delivery system. But even if it didn't kill very many people, which is a possibility, the political effect that it would have had in the target area and the panic it would have caused in the population, I think, would have been very significant indeed.
When in 1998 Iraq blocked UN inspections, the US and Britain felt they had no choice but to launch airstrikes. They feared that Iraq would develop bigger and better biological weapons. With the revelations about Russia and Iraq, a race against time has begun. As more and more countries get access to the technology, US and British forces must try and work out how to defend themselves against bioweapons attack.
the upper deck, we have a cloud 1,500 yards off the port bow, set Mach level 4.
US destroyers like the SS Mitcher are now being built with special defenses. Under attack from biological or chemical weapons, the ship can be sealed. Once the hatches are closed, pressure keeps out contaminated air. Seawater can be pumped over the ship to repel any germs or toxins. But for all this to work, they would need to know that they were being attacked. So the US have been trying to develop detection systems. A few months ago, British troops took part in a 1,000-man biological warfare exercise in Alabama. For the first time, they were shown how to use the American system, the Biological Integrated Detection System.
The two capabilities on the bio side are anthrax and botulinum toxin. Delivery means aerial bombs and Scud.
BIDS is a mobile laboratory. The idea is to set it up behind front lines where it can check continuously to see if there is anything suspicious in the atmosphere.
Outside temperature is 73.1 degrees. Wind direction is at 70 degrees. Liquid samplers
Inside the cramped interior, air is sucked in and analyzed to see if it contains living organisms. If so, they are tested with antibodies to see which viruses or bacteria are involved. Currently, though, it takes BIDS an average of 30 minutes to identify a biological agent, a long wait, during which troops are left dangerously vulnerable.
If in fact you have to wait on the current detection systems, they take anywhere from 15 to 45 minutes, which means that cloud has traveled in that 15 to 45 minutes over a portion of our soldiers, and they've been exposed.
And one of the things I worry about is that we have units exposed, and that commander has to wait for that agent identification. Meanwhile, does he have to worry about setting up decontamination? There are all kinds of issues there, and all the time, while he's trying to make those decisions, that unit maybe can't do its combat mission. And our adversaries on a battlefield are going to take advantage of that.
BIDS may be a step towards defense from bioweapons attack, but it can't stop troops being exposed. Early warning is needed.
We need to have long-range systems in the military because the sooner we know, the sooner we can put our warfighters into protective posture. For the United States Army, the long-range biological standoff detection system is extremely critical to us because it gives us the capability to look out at long distances and to identify that a man-made cloud is present.
The U.S. Army's long-range system can rapidly detect unusual clouds, but it cannot tell what a cloud is made of. It could be anthrax, but it could also be pollen or other organic material.
Backside, medevac 2-2, over. Roger, backside, medevac 2-2, Charlie 130, inbound, your location.
Currently, the new systems do not provide adequate warning of an attack. Significant casualties would be unavoidable, and medical teams sent to treat the victims would face the challenge of trying to isolate these diseased and perhaps contagious soldiers. If there were many thousands of casualties, it would be impossible.
Check the air saturation, please.
97.
Thank you.
Biological weapons on the battlefield are a frightening possibility, but there remains a constraint to their use. Until now, the problem of delivering germ weapons without risking infecting your own troops has never been solved. But in the decade to come, all this is likely to change. Science could be about to solve the problem of delivery once and for all, and create a new generation of germ weapons programmed to identify exactly which people they are meant to attack. At the U.S. Army's Biological Research Center, scientists work to develop vaccines to protect against bioweapons. So far, the range of diseases they needed to be concerned about has been limited. But genetic engineering has radically altered the situation.
When you look at current biological weapons, they have many shortcomings. They may be difficult to absorb. They may only survive in imperfect weather conditions. They may, for example, be destroyed by cold or dryness in the atmosphere. So genetic engineering can be used to make that biological agent, that virus or that bacteria, more resistant, more likely to infect people.
Genetic engineering can improve existing agents, and it can also create completely new diseases. Inside a virus or bacteria, its DNA sequences determine how it behaves. You can now introduce new genes into the DNA and change the nature of the organism. By mixing and matching genes, a whole range of designer diseases could be created.
The revolution in the biosciences that we've seen since the 70s is every bit as profound as the nuclear revolution of 70 years ago, and could have quite devastating impacts on the future biowarfare and bioterrorism threat.
Simple modifications could transform the way an organism behaves. For example, a disease that currently affects animals could be adapted to be lethal to humans.
I give you the example of monkeypox virus. You may be aware, for example, that there has been this program to eradicate globally smallpox virus. It's been a tremendously effective program. And we're very soon approaching the point where there may even be destruction of the final cultures, the final reference stocks of this virus. But there is a new agent that's related to smallpox. It is monkeypox. And monkeypox shares many of the same genetic characteristics as smallpox. 95% of its nucleic acid sequence is shared with smallpox. And so there's this danger that an adversary of the United States might take that virus and use it in the context of a biological weapon.
The greatest concern about the spread of Russian expertise is the claim that they developed a new generation of untreatable diseases, antibiotic-resistant strains or strains that can overcome the immune system.
What is amazing is that genetically altered antibiotic-resistant plague was developed. Genetically altered antibiotic-resistant anthrax was developed. Russians tested this agent using Russian vaccine, so-called STI-1 vaccine, and they were able to show that the normal genetically altered strain very easily overcomes vaccination immunity. This is a real situation.
Designer diseases are worrying, but they still have the disadvantage of all germ weapons. They can infect the wrong people. But genetic engineering has enabled a second and more significant change. It's now possible that this fundamental problem of biological warfare could be solved with the development of viruses and bacteria which attack only certain people while leaving others unharmed.
One hears talk about the development of a kind of ethnic weapon, a weapon that can be targeted to be effective against a particular racial group or group of people. For example, there had been certain developments in South Africa under the old apartheid regime, where they were thinking along these lines of targeting, obviously a particular ethnic group.
In the mid-80s, the South African government sought out an ethnically targeted weapon. Testimony given to the Truth and Reconciliation Commission investigating the crimes of the apartheid regime revealed the extent of these plans.
And this document contained a proposition from someone in Europe. And this guy says he's got a product, a bacteria, which has got the possibility of only affecting, making sick and killing pigmented people. And it was decided that it would be good if the government had this weapon.
At the time, the technology sought by the regime was not available. But with recent advances in genetics, an ethnically targeted weapon is now a possibility. At the FBI crime labs in New York, forensic science is uncovering the kind of genetic information that could be used to target population groups. Identifying individual people from samples of hair or blood has become possible by looking at human DNA. The National FBI database contains over 100,000 samples. They use them to analyze particular sequences in the DNA called junk DNA. Variations in these sequences now allow the FBI to distinguish one person from another.
The differences that we look for are regions of DNA that may vary in length between people, or they may actually vary in sequence between people also. Sometimes these areas of DNA, because they didn't have a known function, were called junk DNA. But I like to think of the expression, one man's trash is another man's treasure. And for the forensic scientists, these regions, because they vary, are sources of vast information for us to use in forensics.
The forensic work has had an unexpected side effect. The FBI databases uncovered genetic markers to identify African Americans, Hispanic Americans, Caucasians, and Native Americans. Any ethnic group might be identifiable, for two major scientific projects are now uncovering more and more information about our genes and how they make us different.
The Human Genome Project is a worldwide collaboration of scientists who are aiming to map where the different genes are within the human chromosomes, what they actually do, what they code for, what they produce as an effect within the body of each of us as individuals. The Human Genetic Diversity Project is trying to collect information on the similarities and differences in different ethnic groups. They are therefore producing information about the different spread of normal genes in different populations.
Scientists collaborating in the Genetic Diversity Project have already identified a genetic marker present in the DNA of Palestinians, but not in the DNA of Israelis. One individual genetic marker wouldn't accurately identify an ethnic group, but a combination could.
If you add together a number of different markers for different populations, you can start to become relatively specific. So, for example, the way in which we handle milk lactose is different between the Asian and European populations. If you then add in blood groups, ABO blood groups, very different distributions. If you also add in height, skin colour, and so on, you start to be able to become specific to your target population.
Once all these genetic markers have been identified, A virus could be designed to look for them on entering the body. It would scan the DNA of cells, looking for the markers. If it finds them, it inserts itself into the host DNA and starts the process of infection. In this way, the virus would be targeted to attack only people who had the right genetic markers. Genetic targeting techniques are already being developed. They are coming from work with a very different aim, the search for a cure for cancer. In Texas, doctors have developed a way of targeting a poison to attack cancer cells. They're adapting a toxin that in the past has been used as a biological weapon.
Well, ricin is a natural toxin produced by the castor bean plant, which you can see here behind me. It's an ornamental plant used in many people's homes for decoration, and it has been used for many, many years in espionage. It's been used in all sorts of criminal activities where people wish to eliminate somebody. And the reason it's so effective is because it takes virtually less than you can see in the palm of your hand to kill an individual. Ricin could potentially help all cancer patients. It could potentially help patients with a whole variety of other diseases where you know what the target cell for the disease is.
Dr. Vitetta has managed to target the ricin poison to attack only the cancerous cells in the body, leaving healthy ones untouched. It does this by recognizing genetic markers. The ricin is attached to an antibody which looks for receptors on the cell surface. Because of a genetic mutation, cancer cells have different receptors from normal ones. The antibody recognizes them and attaches. Only then is the ricin activated to kill the cell. Successful genetic targeting is one of the golden prizes of medicine today. Millions of dollars are being invested in it, in the hope of finding an answer to some of our biggest killer diseases. But it is the very technology that would be needed to identify and kill specific groups of people.
The work that's been done in the pharmaceutical companies in particular, looking for genetically targeted and genetically specific drugs, pharmaceutical agents to treat diseases, is of course the closest example of actually using and targeting that genetic knowledge into specific human beings.
The British Medical Association believe that in the next 10 years, a lethal germ might be created that could select its victims by genetic characteristics. A biological agent that could successfully wipe out entire groups in society. The world's first ethnic weapon. An organism that could target specific people would mark the coming of age of biological weapons. For the first time, there would be no risk of infection to the aggressor. More useful than a nuclear bomb, it would leave land, buildings, and your own troops untouched. And as the proliferation of nuclear technology has shown, once the knowledge is available, it is almost impossible to contain.
Biological weapons have historically used new knowledge, new technology in their development. Although they've not been much used in the past, that has been about their shortcomings, their lack of specificity. Genetic targeting is possible, probably within the next 5 to 10 years. the manufacture of relatively specific biological weapons which are lethal in small volumes would be possible within that time period, and that we have therefore a very short opportunity, a timescale, to put in place proper control mechanisms to make sure these weapons are never developed.